the span of 6.35, and we have to calculate the point load, which is a force. We have to calculate the bending moment. We are given the density of 2.4 kg per cubic meters. We are given the type of the steel, which is high yield steel, 450 MPa. We are given the strength of the concrete, which is 25, with a symbol of FCU. Good. The self weight of the beam, reinforced concrete beam, must be considered into the calculations, and we are given what 4R16. First of all, you must understand, you must be able to interpret this. What does 16 indicate or represent?
The diameter of the bar.
We have the diameter. And what about the 4?
The number of bars.
The number of bars. Good. We are given the overall depth. We are given the effective depth. We don't have the depth then, but we can get that easy by taking this minus that, isn't it?
Yeah.
Good. And we're given the width, and then we have to check the steps that we have to calculate. That is going to help us to find that to manipulate the formula. That means it's gonna be what is gonna be force 4 Bmax divided by the span. So basically this is the formula that you need to conclude your things with. Number 1, what is it that we have to determine? Let's determine what the steel intentions. We know that we are looking for the area, ne? So let's determine the AS, the area of the steel, ne? Intentions. We are looking for the area of the steel intentions. You know that how to calculate the formula. You know how the area of the tensions. If you're given the diameter, you know the area of the circle. Again, you have area of the steel, which is given as the number of the bars multiplied by the pi d squared divided by 4. You can substitute from there, and please make sure that you write, because I'm going to erase it due to our space. We substitute that we have 4 times pi, what is d? 16 squared divided by 4. What is the answer? Can you punch? I don't have a calculator with me here, but I'm going to search one quick. What is it? My calculator is a bit far. Oh, I found it. Make sure you punch, because I'll be punching here to confirm. I'm getting 804, what? 2 5 8. I'm doing like
280.
Yeah, it's 2,2477 from my side. I don't know, Mr. Shani.
Yeah. Yes, it's 2,477.
So
how did you round it off
to 3 decimal place? I did. I did 3 decimal place. Good. And you know that after that you have to check. What? Since we
the
are
minimum area reinforcement.
No, we are checking we are checking the minimum area reinforcement. Yes, check minimum area reinforcement. Reinforcement. Okay, good. Reinforcement. And how do you calculate that? You know the formula, which is given from the table 23, whereby it's going to be 100 AS divided area of the steel that you got, divided by the area of the column, concrete column, which is going to be that formula. You don't just write things. That formula, it's found in the table table 23. That is a mark for that. Which clause is that? It's clause clause number 4.11.54. Is it correct? Yes, it's correct. It's correct. Yes, it is correct. There's a mark for that. There's a mark for that. Then you could, which page is that, Munene? You said we refer these tables from the second page. Which page is that?
Page 119.
119.
Yeah, page 119.
119. Good, thank you.
Yeah.
119. 119. Good. Good. 119. Now, if we try to substitute that, we're going to say, okay, fine. I'm substituting that. I'm going to have 100 AS. What is an AS? And AS, we calculated it. We got what? We got 804, comma what? 248 divided by what? The area of the steel. You take the overall, multiply by what? Multiply by the width. The overall is what?
425. 425.
425 by what? By 230. What is the answer?
Yeah. 0.823.
If there's something that I'm not aware of in terms of reasoning, tomorrow I'm going to the college. There's a lady that used to teach me there. She's good. She's good. She knows these things. She's good. She's gonna add. We're just gonna add these things. I'm getting 0.82. Let's say make it to this one place, because remember we are going to compare that with what? With on the minimum percentage. You see the minimum percentage one? What? There by 450, because we said it's the white is a high yield, isn't it?
Yeah.
You see 450, that one, we're going to compare that. The section subjected mainly to the tensions, is it greater than or less than 0.45 under 450? If we were dealing with a mild, we're going to compare it with 0.8. So if the area that we got is greater than the actual strength that is given there as 0.45, therefore it can support, is strong enough. But if it's less than that, it is not okay. That's why normal of the time, like if you check on the textbook, the reason is just okay. But with me as giving the skill as like to pass those things, I don't think writing okay, it does not affect your next answer most of the time. I don't know if you get me.
Yeah.
So, but no. So if we compare our answers, we check here. Okay, fine. This answer that we got is greater than. Is it greater than or less than 0.45?
It's greater.
Therefore, it is strong enough. We're going to check this. We are going to check what the maximum one.
Yeah.
Check the maximum tension reinforcement. We also have the formula that is given from the same clause there. The same clause. Because this thing is the step number one, still on the step number one. But we're going to say the 4% of that, 4% of the area of the concrete of area of the concrete. So you know how to do 4% of that. 4% is 4 over 100 multiplied by what? Multiplied by the area there, which is 425 by what? By 230. You get it?
Yeah.
What is the answer?
Yes. 3,910.
3,000?
910.
Millimeters is the area squared. Good. Any question that you have?
No.
Because remember, whatever that we before I can
No.
no, this one we know. Can I erase this space, this drawing?
Yeah.
Now, this, remember, for us to check, how do you get the guidance that okay, this is the step that I must start with? I gave you an idea here that we have to look for the point load, but you know that you have to calculate that. the Bmax. But where do you get the Bmax? There's a formula that we have to know, which is area of a steel. We have two of area of steel. The area of steel is equals to what? Bmax is represented by capital letter M. So it's a Bmax divided by what? 0.877 and then it's Fy.
Z.
Yes, Fyz. But what is it that you don't have here? You check something. Oh, I don't have the Bmax. I have to calculate it. But for me to come here, I must get the Bmax. Do you have the Z? No, you don't have the lever arm. Do you have the Fy? Yes, I have the Fy. You get it?
Yeah.
So what is it that you have to calculate now? That means you have to calculate the distance of the lever arm, ne?
Yeah.
So you can calculate the lever arm. The lever arm. And you know the formula for the lever arm?
Yes.
What is the formula?
It's D times 0.5.
Z equals to D into
0.5
0.5
plus the square root
of
0.25
0.25 minus K
minus
prime.
K1 divided by
K prime. Yes, that's how it is. You know, that is found in clause what? 4.3.3.4, ne?
Yes.
Yes, yes. That's how it is. That's how it is. There's something that I need to check so that I can explain something quick again, because we continue reminding each other about this. Remember, in terms of K, we have a K prime and a normal K. Ne?
Yeah. Yeah.
We can also, there's this formula, but I don't think we're going to use this one. This formula that we talked about here, we said this formula, it was it's K, which is given as what? Bmax divided by what? FCU by what? By BD squared. Ne?
Yeah.
But checking from what we are supposed to calculate, do you think this is not gonna help us with anything? If we calculate it, it's gonna take us. We can't use this one. Why? We don't have Bmax, ne?
Yeah.
So if we were given the Bmax, it was gonna be easy for us to calculate what? And you know, the only way to get the Bmax, you must have a point load. Otherwise, I don't even have a point load. That means this one is not necessary. But what I'm about to explain is this. Where do you use K prime? There's a formula that you know I specified. I talked about the 8th. I said it's Z, which is what? 0.5 plus square root of 0.25 minus K prime divided by 0.9. Then therefore it says less than or equals to 0.95 diameter. I mean like the depth. You remember this formula?
Yeah.
I said you only apply this formula if your K is less than K prime. But in this way, we're not gonna apply that theory. Ne? It's your notes. I'm just giving you notes. So let's just go straight and prostitute from this. Yes.
So, how do you know if you have to use the K value or the 0.156 or K prime?
The K prime is constant.
Yeah, but when you're calculating, how do you know which one you have to use?
And this man, that means you will have to you have calculated this, ne?
Yeah.
You must compare eventually, but I'm not gonna talk. I don't want to talk about these two theories because it does not relate with the problem at the moment.
Okay.
Yeah. So I'm not gonna give you a reason why are we supposed to use K, not K prime, because this problem does not require us to calculate that normal K that we are talking about now. But we're gonna talk about it some other time.
I've seen where they ask you to calculate the value of K. That's when they use that value.
Yes,
If they
that's what I'm saying.
if they don't ask,
That's what I'm saying,
you use K
Mr.
prime.
Menier. That's what I was trying to say. That's what I was trying to say. We're gonna get to that part. Are we good?
Yes.
So
Yes, sir.
when we substitute there, what is the effective depth here? Oh, what was the effective depth? Because this small d is the effective depth. What was the effective depth? Because I erased it, but
375.
So it's gonna be what? It's gonna be 375. 375, please. 375. Is it still clear, or I must just tell yes? Into 0.5, square root of 0.25 minus 0.156. We know that divided by 0.9. Please, what is the z there?
291,33.
291 point what?
33
33
millimeters.
That's what you get. Good. That's what you're getting. Mama Tobil, are you getting the same answers there? Oh, Mama Tobes is quiet. Let me see. Is she still here? So, Khoto, are you good? Hey, thumb up. But I'm full Ted. I'm Ted. Good. Good. Now, we are going to calculate the Bmax. From the formula that was written here, I said AS equals to what? The Bmax, but it's represented by capital letter M. I'd love it to write the B as a Vmax. Divided by what? I said what? 0.87, then F multiplied by what? FYZ. This is found in clause what? Is it clause what? 4.3.3.4. Ne? We have AS, we have FY, we have Z now. We're looking for this Bmax. You make that substitute the formula, it's going to be what? Bmax equals to what? AS 0 multiplied by 0.87 multiplied by FY multiplied by Z. And then you substitute one way. What was our AS? Our AS, we got what? Our AS was 804, 248 by what? By 0.87. FY, what was the FY? FY, what is our FY?
250 MPa. 450.
Sorry?
250 MPa. 250 MPa. No, it's 450 SJ because it's high yield. High yield, FY.
I was still sure because the question said what? What is it? The beam is reinforced with high yield tensile steel reinforcement. So it's 450, ne?
Yeah.
So it's gonna be 450. 450. And then what is our Z? Our Z is given as we got what?
It's
291.
337.
337. Okay, fine. When you punch that, what is the answer?
4 times 4 pounds 87 times 52 times 2 yeah. Divided by 91,700.
Shelling, what are you getting?
91,700.
Mr. Shelling, what are you getting? Punch. I will punch.
You can punch because I can't see those values there, SJ.
Oh, you were writing your values. You substitute on your own. You were writing your values. We have the area of the steel multiplied by 0,87 multiplied by Fy multiplied by Z. You know those values. You don't know them?
What's the lever arm? I'm not writing down.
You must write it down. The lever arm is 291,337 according to Mama Tobile.
Times 10 to the 6 is 96.179.
No, I'm getting 91.73. I don't know.
91,700.
Yeah. You press engineering there. If you get the big number, you press engineering.
Oh, 91.7.
91.01. I'm getting 91.73. That will be in kilonewtons. We know that kilonewtons by meter. We know that is a Bmax, ne?
Yeah.
So after that, what is it that you have? Can I erase?
Yeah.
Now after that, you know that you have to. Now you have your Bmax. You're going to calculate what is the point load. Actually, yeah, the question is what we were looking for. Yeah, this is the maximum what? Calculate the maximum one. The maximum one, that means we can think of that, those formulas, you know, when we are calculating the total design load, that formula of Qn and what, and Gn.
Yeah.
Good, we are going there. But for us to go there, we must pass through the total load. Let's calculate what the total load. How do you calculate the total load? I've already given you the answer, whereby it's going to be Bmax equals to FL divided by 4. You cross multiply, you're looking for the point load, is going to be FL. It's going to be Bmax multiplied by 4 divided by the span. So what is the Bmax? The Bmax, we said we are getting what? 91.73 by 4 divided by what was it? Was 6.35, ne? The span.
Yeah, 6.35.
Yes, that's how it is. What is the answer that you are getting?
It's 57.783.
57 point what?
783
783 kilonewtons. And then we are continuing.
Design load.
So now we're going to calculate what? The dead load.
Sir?
Yes, ma'am.
a big number, press
engineering.
Oh. Shift.
No, you don't press shift. There's engineering in your calculator. This is engineering, E and G.
E and G.
What calculator are you using?
Oh, yeah, I can see it. Thank you.
A dead load, you know how a dead load. What is the formula for a dead load? Before I can say a lot of
volume times density times GA times 10 to the minus 3.
Density times what?
GA.
Gravity, ne?
Times 10 to the 3.
Yeah, we'll do that when we substitute everything. A volume, it's per meter. A volume of the concrete we take what the width. The width was let's do that in meters. It was 425, ne?
Yeah.
0.425 times what? 0.23, it was 230. You multiply it by 1 because it's per meter. It becomes a volume. Multiply by density. Multiply by 9.8 times 10 to the power negative 3, ne?
Yes.
Yes. What is the answer? Remember that
2.30.
What?
2.30 kilonewtons meter.
2.30. 30, just like that. There's no other value.
301.
1 kilonewtons per meter. Now we go for the other one. We are going for what? The maximum, the UDL, ne? The imposed load.
There's no imposed load, but
yeah, so we are. I mean, like the what do you call this? We need to find the total load. Sorry, the total load. How do you find the total load? You find it by using that formula, Gn plus what? 1.6 Qn. The aim here is to find Qn. That is our maximum point load. Maximum point load. Well, you already have the total. Remember, you already have the total load, eh?
Yeah, substitute.
557, what? 783 equals to 1,2. Gn is 2.30 plus 1,6 Qn. You are looking for the Qn. I believe that you did maths. You can find the Qn now. I believe that we're gonna have the same answer. Then we're gonna continue checking difficult question papers, and then we try to solve it out. That's it for